Hi students, welcome to the LMS portal. Today we are going to discuss session 9 of Unit 5 Integral Calculus and Applications. Quickly we recap the things we have discussed in the previous session. In the previous session we discussed about definite integrals, simple problems on definite integrals, assignment questions and multiple choice questions. In this session we are going to discuss about simple problems on definite integrals, evaluating definite integrals by substitution method, assignment problems and multiple choice questions. So directly we start with the simple problems on definite integrals. In the previous session also we discussed about some simple problems on definite integrals. Here also we are discussing some simple problems continued. In the previous session we discussed about direct integration problems, and here we can't do direct integration. For that given functions we have to substitute some other formulas and then we have to integrate. That kind of problems we are going to discuss in this session. So evaluate integration from 0 to pi by 2 sine square x dx. We know that there is no direct formula for integration for sine square x dx. So in the place of sine square x dx, we have to substitute some other values. For that we can do direct integration. Andre sine square x na direct agi integration ಮಾಡ್ಲಿಕ್ಕೆ ಯಾವುದು ಫಾರ್ಮುಲಾ ಇಲ್ಲ. ಹಾಗಾಗಿ sin square x ಗೆ ರಿಲೇಟಿವ್ ಇರತಕ್ಕಂತ ಯಾವುದಾದರೂ ಒಂದು ಫಾರ್ಮುಲಾ ಬರಿಬೇಕು. ಆ ಫಾರ್ಮುಲಾ ಅನ್ನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡೋ ತರ ಇರಬೇಕು. ಅದನ್ನ ನಾವು ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ನಿಮಗೆ ಗೊತ್ತಿದೆ ನಾವು ಮಲ್ಟಿಪಲ್ ಆಂಗಲ್ಸ್ ಅಲ್ಲಿ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಯಲ್ಲಿ ಫಾರ್ಮುಲಾ ತಗೊಂಡಿದ್ದೀವಿ. cos 2x ಫಾರ್ಮುಲಾ ಇಸ್ 1 minus 2 sin square x. ಆ ಫಾರ್ಮುಲಾವನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು we can write sin square x is equal to 1 minus cos 2x divided by 2. This is the formula we have discussed in trigonometry in multiple angles. That is sin square x is equal to 1 minus cos 2x divided by 2. So in the place of sin square x we can substitute 1 minus cos 2x divided by 2. Here 1 by 2 is a constant term. We can take it outside of the integration. Now integration of 1 is x. Integration of cos 2x is sin 2x divided by 2. This is already well known to you, because in integration also we have discussed about all these things. Just we are now concentrating on applying the limits here, upper limit and lower limit simplification. Okay. So integration of 1 is x. Integration of cos 2x is sin 2x divided by 2. Now apply the upper limits and the lower limit. Upper limit is x is here pi by 2 minus sin 2 into, in the place of x we have to substitute pi by 2. So pi by 2 minus sin 2 into pi by 2 whole divided by 2 minus of, we have to apply lower limit. In the place of x we have to put 0. Here also in the place of x we have to put 0. So pi by 2 minus sin 2 pi by 2 whole divided by 2 minus of 0 minus sin of 2 into 0 divided by 2. So if we simplify this, we get here pi by 2 will remains as it is. Here 2 gets cancels. It remains with sin pi. Sin pi means it is sin 180 degree and sin 180 degree is 0. So we get 0 divided by 2. And here 0 is there. Again sin 0 is also 0. Here sin pi, that is also 0. Here sin 0, that is also 0. So this term becomes 0, this term becomes 0 and this term becomes 0. It remains with 1 by 2 into pi by 2. Therefore we get the answer is pi by 4. That is the required solution. Therefore integration from 0 to pi by 2 sin square x dx equal to pi by 4. Now we move on to the another problem here. Evaluate integration from 0 to pi by 4 tan square x dx. So again for tan square x there is no direct integration. So for tan square x we have to write some other formula. We know that 1 plus tan square theta is equal to secant square theta. By using that formula, tan square x can be written as secant square x minus 1. We know that 1 plus tan square theta is equal to secant square theta. Therefore tan square theta is equal to secant square theta minus 1. So in the place of tan square x, I have substituted secant square x minus 1. Now integration of secant square x is tan x minus integration of 1 is x between the limits 0 to pi by 4. Now apply the limits. Upper limit is pi by 4, lower limit is 0. So tan pi by 4 minus pi by 4 minus of tan 0 minus of 0. You know that tan pi by 4 is 1. Pi by 4 will remain as it is. Tan 0 is 0 and this term is also 0. So this whole term vanishes. It remains with 1 minus pi by 4. Therefore, integration from 0 to pi by 4 tan square x dx is 1 minus pi by 4. Another one is evaluate integration from minus pi by 4 to plus pi by 4 integration of sin square x minus cos square x dx. Again, for these two also there is no direct integration, but we have formula for this one. That is, integration of sin square x minus cos square x can be taken as minus cos 2x. We know that again in the multiple angles, cos 2 theta is equal to cos square theta minus sin square theta. Since we need sin square theta minus cos square theta, we have to take minus on both sides. If you multiply by minus on both sides, we get minus cos 2x is equal to sin square x minus cos square x. Therefore, in the place of sin square x minus cos square x, substitute minus cos 2x. Now we integrate this cos 2x. Integration of cos 2x is sin 2x divided by 2. Here you can know that cos 2x is equal to cos square x minus sin square x. So here we have substituted sin square x minus cos square x is minus cos 2x. Integration of cos 2x is sin 2x divided by 2. Lower limit is minus pi by 4. Upper limit is plus pi by 4. Then apply the limits. Minus will remain outside here. The sine of 2 into pi by 4 divided by 2 minus sine of 2 into minus pi by 4 divided by 2. You can keep 1 by 2 outside also, no problem. Then if you simplify this, minus 1 by 2 will remain outside. Here 2 ones are, 2 twos are, we get sine pi by 2 minus of, again here also sine minus pi by 2. You know that minus 1 by 2 will remain as it is. Sine pi by 2 is 1. Again sine of minus 90 is minus sine 90. So it becomes plus sine pi by 2. Again sine 90 is 1. So here also sine 90 is 1. Here also sine 90 is 1. This minus will come here. It becomes plus. So we get 1 plus 1 2. 2 gets cancelled. It remains with minus 1. Therefore, integration from minus pi by 4 to plus pi by 4 sin square x minus cos square x dx is minus 1. Similarly, another one, integration from 0 to pi by 2 sin x plus cos x whole square dx. Here you can observe it is of the form a plus b whole square. First we have to apply a plus b whole square formula, that is a square plus b square plus 2ab. So here a is sin x, b is cos x. So a square means sin square x, b square means cos square x, plus 2ab means 2 sin x cos x. Sin x plus cos x whole square can be written as sin square x plus cos square x plus 2 sin x cos x. And we know that sin square x plus cos square x value is 1. 2 sin x cos x is sin 2x formula that we have discussed in multiple angles. Sin 2x is 2 sin x cos x. So this value becomes integration from 0 to pi by 2. Sin square x plus cos square x is 1. 2 sin x cos x is sin 2x. Now we can directly integrate. Integration of 1 is x. Integration of sin 2x is minus cos 2x divided by 2. Integration of 1 is x. Integration of sin 2x is minus cos 2x divided by 2 between the limits 0 to pi by 2. Now apply the upper limit and the lower limit for these things. We get pi by 2 minus of cos of 2 into, in the place of x, pi by 2 whole divided by 2 minus x is 0, here also x is 0, we get 0 minus cos of 0 whole divided by 2. Here pi by 2 remains as it is, 2 gets cancels, it is cos pi remains, cos pi by 2 minus, here it is 0, again cos 0 is 1, we get minus 1 by 2. Again pi by 2, and we know that cos 180 degree is minus 1, so it becomes minus into minus plus 1 by 2, and here also minus into minus plus 1 by 2. So pi by 2 plus 1 by 2 plus 1 by 2, we get pi by 2 plus 1. Therefore, integration from 0 to pi by 2 sin x plus cos x whole square dx is equal to pi by 2 plus 1. So that is how we can solve the definite integrals. Again, another one problem is there. Evaluate integration from 0 to pi by 2 sin cube x into dx. Again, there is no direct formula for sin cube x dx, but in the compound angles we have studied, in the multiple angles also we have studied sin 3x formula. By using sin 3x formula, we can write sin cube x is equal to 1 by 4 3 sin x minus sin 3x. This is the formula for sin 3x. Sin 3x is equal to 3 sin x minus 4 sin cube x. We need only sin cube x, so we can take this one to this side, sin 3x to this side. So it becomes 4 sin cube x is equal to 3 sin x minus sin 3x. We need only sin cube x, so sin cube x is equal to 1 by 4 3 sin x minus sin 3x. Now what we have to do is, we have to integrate this one directly. 1 by 4 remain as it is. Integration of sin x is minus cos x. Integration of sin 3x is minus cos 3x divided by 3. Since minus is there, it becomes plus cos 3x by 3 with upper limit pi by 2, lower limit 0. Now substitute the values, that is 1 by 4 into minus 3 into cos of upper limit is pi by 2 plus cos of 3 into upper limit is pi by 2 divided by 3 minus of again minus 3 into cos of lower limit is 0 plus again cos of lower limit is 0 divided by 3. If we simplify, cos pi by 2 is 0, so this value becomes 0. Cos 3 pi by 2 value is also 0, so this whole value becomes 0. So these two become 0. Now minus of minus 3, cos 0 is 1. Here also cos 0 is 1. So we get minus 3 plus 1 by 3. Now if you take LCM, 3 will be the LCM. So 3 3s are 9 plus 1. Minus 9 plus 1 divided by 3. That will become minus 8 divided by 3. Since minus is there, minus into minus plus 8 divided by 3. Then if you divide by 4, 4 1s are 4 2s are, we get 2 by 3. That is, integration from 0 to pi by 2 sin cube x dx is equal to 2 by 3. Now we move on to another one here. Integration from 0 to pi by 2 cos square x divided by 1 minus sin x dx. Again here also we don't have direct formula here, but we know that 1 plus cos square x is equal to 1 minus sin square x. We know that sin square theta plus cos square theta is equal to 1. Therefore, cos square theta is equal to 1 minus sin square theta. That means cos square x is equal to 1 minus sin square x. Here you can write 1 as 1 square minus sin square x. There is no change. That will be in the form a square minus b square. So a square minus b square can be written as a plus b into a minus b. That is, a plus b means a is 1, b is sin x. So 1 plus sin x. A minus b is 1 minus sin x. We have used sin square x plus cos square x equal to 1. Cos square x equal to 1 minus sin square x. Also here it is 1 square minus sin square x. That is a square minus b square form. That is a plus b into a minus b. By using that, it become 1 plus sin x into 1 minus sin x. Now what is the thing happen? 1 minus sin x, 1 minus sin x gets cancels. it remains with 1 plus sin x. Now integration of 1 is x, integration of sin x is minus cos x between the limits 0 to pi by 2. Now apply upper limit pi by 2 minus cos pi by 2 minus lower limit 0 minus cos 0. Here pi by 2 remains, cos pi by 2 0, this value is 0, cos 0 is 1. So it remains with minus 1, it becomes minus into minus plus 1. So final answer is pi by 2 plus 1. Therefore, integration from 0 to pi by 2 cos square x divided by 1 minus sin x dx is pi by 2 plus 1. That is the answer we got here. Now we are moving on to another type of problem, that is evaluate integration from 0 to pi by 2 sin 3x cos x dx. This problem can be done by transformation formula. Okay, so we know that sin A cos B, cos A sin B, cos A cos B, sin A sin B formulas. So we know that sin A cos B is 1 by 2 sin of A plus B plus sin of A minus B. That is the formula we know. So 0 to pi by 2 sin 3x cos x dx can be written as 1 by 2 0 to pi by 2 sin 4x plus sin 2x dx. By using this formula, sin A cos B equal to 1 by 2 sin of A plus B plus sin of A minus B. Here A is 3x, B is x. So 3x plus x 4x, 3x minus x is 2x. So if we simplify this, 1 by 2 will keep it as it is. So integration of sin 4x is minus cos 4x divided by 4. Integration of sin 2x is minus cos 2x divided by 2. That is well known. Integration of sin 4x is minus cos 4x divided by 4. Integration of sin 2x is minus cos 2x divided by 2. Now between the limits 0 to pi by 2, 1 by 2 you can keep, minus also is there, minus you can take it outside, minus 1 by 2 cos 4x by 4 minus plus cos 2x by 2 between the limits 0 to pi by 2. So minus 1 by 2 we can keep aside, apply upper limit and lower limit. Upper limit is pi by 2, lower limit is 0. That is cos 4 pi by 2 divided by 4 plus cos 2 into pi by 2 divided by 2 minus lower limit cos 4 into 0 divided by 4 plus cos 2 into 0 divided by 2. We have taken this minus 1 by 2 completely outside. First we have applied upper limit pi by 2, next we put minus, then we apply lower limit 0 wherever x is present. Now if we simplify, minus 1 by 2 will remain as it is. Here 2 1s are 2 2s are, cos 2 pi, that is cos 360 will remains. Here also cos pi remains, 2 2 gets cancels, it is cos pi by 2. Here cos 0 by 4, here cos 0 by 2. And we know that cos 360 value is 1, cos 180 degree value is minus 1, cos 2 pi is 1, cos pi is minus 1. Similarly cos 0 is 1 here, here also cos 0 is 1. So if we simplify this, we get 1 by 4 minus 1 by 2 minus 1 by 4 minus 1 by 2 minus 1 by 4 plus 1 by 4 gets cancels. Then minus 1 by 2 minus 1 by 2 becomes minus 1, minus into minus plus 1 into 1 by 2 is plus 1 by 2. Therefore, integration from 0 to pi by 2 sin 3x cos x dx is 1 by 2. Same kind of another problem is here. Evaluate integration from 0 to pi by 2 cos 3x into cos 2x dx. It is of the form cos A cos B. We know that cos A cos B formula is 1 by 2 cos of A plus B plus cos of A minus B. Cos A cos B formula is 1 by 2 cos of A plus B plus cos of A minus B. Here A is 3x, B is 2x. So if you substitute here, cos of 3x plus 2x is 5x, cos of 3x minus 2x is cos x. That's what we have done here. By using transformation formula, we have substituted a equal to 3x, b equal to 2x, and simplified here, we get cos 5x plus cos x. Now directly integrate. Integration of cos 5x is sin 5x divided by 5. Integration of cos x is sin x. Integration of cos 5x is sin 5x by 5. Integration of cos x is sin x. Between the limits 0 to pi by 2. So we keep 1 by 2 outside. Apply upper limit first and then lower limit. Sin 5 into pi by 2 by 5 plus sin pi by 2. We have put here x equal to pi by 2. Minus, put x equal to 0 here. Sin 5 into 0 by 5 plus sin 0. So sin 5 pi by 2 value is 1 by 5 plus sin 90 is 1. Similarly, here sin 0 is 0. Here also sin 0 is 0. So this whole term becomes 0. It remains with 1 by 5 plus 1. Here LCM will become 5. 5 into 1 is 5 plus 1. So we get 6 by 5, that is 3 by 5. Therefore, integration from 0 to pi by 2 cos 3x into cos 2x dx is equal to 3 by 5. So I have given some assignment problems based on this kind of problems here. You can try this one. Integration from minus 4 pi by 4 to plus pi by 4 cos x plus 2 secant square x dx. Integration from 0 to pi by 2 sin 4x plus cos 2x dx. Integration from 0 to pi by 2 sin x minus cos x whole square dx. Integration from 0 to pi by 2 sin 4x cos 2x dx. Integration from 0 to pi by 2 cos 3x sin x dx. Integration from 0 to pi by 2 cos 5x cos 3x dx. Integration from 0 to pi sin 3x sin x dx. And integration from 0 to pi by 2 cos square x dx. You can try this problem at your level. Next, now we are going to discuss about evaluation of definite integrals by substitution method. ಅಂದ್ರೆ substitution method ಅಲ್ಲಿ definite integration ಅನ್ನು ಹೇಗೆ ಮಾಡೋದು ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿದೆ. ಅದರ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವು definite integrals ಅನ್ನು ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬಹುದು ಅನ್ನೋದನ್ನ ನೋಡ್ಕೊಳ್ತೀವಿ. Here also integration is already known to you. ಇಂಟಿಗ್ರೇಷನ್ ಬಿಟ್ಟು ಉಳಿದಿರೋ ಪಾರ್ಟ್ ಏನಿದೆ ಡೆಫಿನೆಟ್ ಇಂಟೆಗ್ರಲ್ಸ್ ಅಲ್ಲಿ ಲಿಮಿಟ್ ಅನ್ನ ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಹೇಗೆ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನ ಮಾತ್ರ ನಾವಿಲ್ಲಿ ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದೇವೆ. So we will consider this problem here. Integration from 0 to pi by 2 sin cube x into cos x dx. Here what you have to do, as we have done already in the previous sessions, ಇಂದಿನ ಸೆಷನ್ಸ್ ಗಳಲ್ಲಿ ನೀವು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ಹೇಗೆ ಮಾಡೋದು ಅನ್ನೋದನ್ನ ತಿಳ್ಕೊಂಡಿದ್ದೀರಾ. So they are given integration from 0 to pi by 2 sin cube x cos x dx. Here which one you have to take here substitution here. So here we have to put sin x equal to t. ನಾವಿಲ್ಲಿ sin x is equal to t ಅಂತ ಹೇಳಿ ತಗೋಬೇಕಾಗತ್ತೆ, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಅದಕ್ಕೆ ಪವರ್ ಏನಿದೆ ಜಾಸ್ತಿ ಇದೆ. ಇದನ್ನೆಲ್ಲದನ್ನು ನಿಮ್ಮ ಹಿಂದಿನ ಸೆಷನ್ ಗಳಲ್ಲಿ ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದಾರೆ. ಹಾಗಾಗಿ ಯು ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ ಟೇಕ್ sin x is equal to t, differentiate with respect to x, differentiate this term with respect to x, then we get cos x dx is equal to dt. ಇದನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ we get cos x dx equal to dt. Also when we are using definite integrals, ನಾವು ಬರೀ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಮಾಡಿದ್ರೆ ಸಾಕಾಗಲ್ಲ. ಇಲ್ಲೇನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ, ಅವ್ರೇನ್ ಲಿಮಿಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಆ ಲಿಮಿಟ್ಸ್ ಗೆ ನಾವು ವೇರಿಯೇಷನ್ಸ್ ಕೂಡ ಚೇಂಜ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ವೇರಿಯೇಬಲ್ಸ್ ಇಲ್ಲಿ they are given x varies from 0 to pi by 2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆದ್ರೆ ನಾವು ಈಗ sin x ಬದಲು t ತಗೊಂಡಿರೋದ್ರಿಂದ here the limits also changed based on this concept. Okay, so that's why when you take x equal to 0, x equal to 0 ಇದ್ದಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, t is equal to sin 0 ಆಗುತ್ತೆ. Then when it becomes sin 0, what is the value of sin 0? 0. Therefore when x is equal to 0, then t is also 0. Similarly when x equal to pi by 2, ಈ ಒಂದು ಲಿಮಿಟ್ ಅನ್ನು ನಾವು ತಗೊಂಡಾಗ x is equal to pi by 2 ಆಗುತ್ತೆ. Therefore t is equal to sin pi by 2 and sin 90 degree value is 1. So when x is equal to pi by 2, t is equal to 1. As per problem they have given x equal to 0, x equal to pi by 2. Since we are replacing sin x by t, here we have to change the limits also. Therefore when x equal to 0, we found t equal to 0. When x equal to pi by 2, we got t is equal to 1. Now, substitute all these values in equation 1. Equation 1 ಅಲ್ಲಿ ಈ ಎಲ್ಲಾ values ಗಳನ್ನು substitution ಮಾಡ್ತೀವಿ. Then we get integration from 0 to pi by 2 sin cube x cos x dx becomes limit ಏನಾಗಿದೆ x equal to 0 ಇದ್ರೆ t equal to 0. We put 0. When x equal to pi by 2, t equal to 1. So we substituted here. Then sin cube x means here if we put sin x equal to t. Therefore sin cube x means t cube. In the place of cos x dx, we have replaced dt. So, ಈ x ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ variables ಎಲ್ಲ now we have changed into t. Now it is very easier one. Integration of t cube. Integration of t cube is t power 4 divided by 4 with the limits 0 to 1. And here we take 1 by 4 outside. Put t equal to 1 here. So 1 power 4 minus lower limit is 0 power 4. This will become 0. It remains with 1 by 4. Therefore, integration from 0 to pi by 2 sin cube x cos x dx is equal to 1 by 4. Similarly, another one is there. Evaluate integration 0 to pi by 4 tan 5x tan power 5x into secant square x dx. Here what is the thing is, which one you have to take t. ಯಾವುದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನ ಹೇಗೆ ನೋಡ್ಕೊಳ್ತೀವಿ ಅಂದ್ರೆ ಅದಕ್ಕೆ ಒಂದು ಫಾರ್ಮುಲಾ ಇದೆ. ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ಇಂಟು ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಪವರ್ ಎನ್ ಡಿ ಎಕ್ಸ್ ಇದ್ದಾಗ ಎಫ್ ಆಫ್ ಎನ್ ಎಕ್ಸ್ ಪವರ್ ಎನ್ ಪ್ಲಸ್ 1 ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಪ್ಲಸ್ 1 ಅನ್ನ ನಾವು ಇಂಟಿಗ್ರೇಷನ್ ತಗೊಳ್ತೇವೆ. ಅಂದ್ರೆ ಇಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಟರ್ಮ್ ಅನ್ನ ನಾವು ಟಿ ಅಂತ ತಗೊಂಡ್ರೆ ಅದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಇನ್ನೊಂದು ಟರ್ಮ್ ವ್ಯಾನಿಶ್ ಆಗಬೇಕು. ಆ ಒಂದು ಟರ್ಮ್ ಅನ್ನ ನಾವು t ಅಂತ ತಗೊಳ್ತೇವೆ. ಯು ನೋ ದಟ್ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಆಫ್ tan x is what? secant square x dx. ಹಾಗಾಗಿ we have to put tan x equal to t. ಅಥವಾ ಹೈಯೆಸ್ಟ್ ಡಿಗ್ರಿ ಟರ್ಮ್ ಯಾವ್ದಿದೆ, ಇಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ಪವರ್ ಯಾವ್ದಿದೆ ಅದನ್ನ ಕೂಡ ನಾವು t ಅಂತ ಹೇಳಿ ತಗೋಬಹುದು. So we have to put tan x equal to t. Again we have to differentiate this one with respect to x. We get differentiation of tan x is secant square x dx is equal to dt. If you differentiate this, differentiation of tan x is secant square x dx equal to dt. Now, also we have to change the limits. When x equal to 0, t is equal to tan 0 is 0. So, when x equal to 0, t equal to 0. When x equal to pi by 4, t is equal to tan pi by 4, that is tan 45 degree, that value is 1. Therefore, when x equal to pi by 4, t is equal to 1. Now substitute all these values in equation 1. It becomes integration from 0 to pi by 4 tan power 5x secant square x dx equal to, here when x equal to 0, t equal to 0. So here 0 becomes, when x equal to pi by 4, t is equal to 1. So 1 becomes here. Then tan x is t. So we get t power 5. And secant square x dx is dt, so we have taken it as dt. In the place of secant square x dx, it is dt. And then it's very simple. Integration of t power 5 is t power 6 divided by 6 between the limits 0 to 1. We take 1 by 6 outside, apply upper limit, that is 1 power 6, minus apply lower limit 0 power 6. 0 power 6 is 0, 1 power 6 is 1. 1 into 1 by 6 is 1 by 6. And that is the required answer. Integration from 0 to pi by 4 tan power 5x into secant square x dx is 1 by 6. We move on to another one here. Evaluate integration from 0 to a x sin x square dx. X into sin x square dx between the limits 0 to a. Here we call again this as equation number 1. We have to take it here highest term, put x square is equal to t. We don't have to take sin x square equal to t, because if you take sin x square equal to t, then you don't get this value here. Again it will continues. Okay, that's why we have to take x square equal to t, differentiate with respect to x. We get, if you differentiate x square, it is 2x dx is equal to dt. Therefore, we need only x dx here. It is present x dx only. So, x dx is equal to dt divided by 2. X square equal to t. If we differentiate, 2x dx equal to dt. Then it becomes x dx is equal to dt divided by 2. Also, we have to change the limit. When x equal to 0, t will also become 0. When x equal to a, t becomes a square. In the place of x, we have to put a here, it becomes a square. So when x equal to 0, t is equal to 0. When x equal to a, then t equal to a square. Now substituting all these values in equation 1, we get here 0 to a x into sine square x dx becomes 0 to a square sine t into dt divided by 2. That means 0 is 0. In the place of a, we have to substitute a square. Sine x square, in the place of x square, we have to put a t. So it becomes sine t. Then x dx can be replaced by dt divided by 2. So we got dt divided by 2. Now we have taken 1 by 2 outside, and also integration of sin t is minus cos t. We have taken minus also outside. So minus 1 by 2 comes outside, and integration of sin t is minus cos t, and minus is here. So cos t between the limits 0 to a square. Now apply the upper limit. Upper limit is a square, lower limit is 0. That is minus 1 by 2 cos of a square minus cos of 0. Therefore, we get minus of cos a square minus this value is 1 whole divided by 2. Or you can write minus 1 by 2 into cos a square minus 1. Therefore, integration from 0 to a, x into sine of x square dx is minus of cos of a square minus 1 whole divided by 2. Now we take another one. Integration from 0 to 1 x into x square plus 1 whole square dx. We call it as equation number 1. Put x square plus 1 equal to t, because that is the largest term. We have to put x square plus 1 equal to t. Differentiate with respect to x. We get differentiation of x square is 2x dx. Differentiation of 1 is 0. Differentiation of t is dt. So we get 2x dx is equal to dt. Therefore, x dx equal to dt divided by 2. We have differentiated, put x square plus 1 equal to t. Differentiate, we get 2x dx equal to dt. Therefore, x dx is equal to dt divided by 2. Also, when x equal to 0, t will become 0 square plus 1, that is 1. When x equal to 1, t equal to 1 plus 1, that is 2. You can observe here, when x equal to 0, then t will become 1. When x equal to 1, then t will become 1 square is 1 plus 1, that is 2. Now substitute all these values in equation 1. We get integration from 0 to 1 x into x square plus 1 whole square dx is equal to integration from, in the place of 0 we put 1, in place of 1 we put 2, in place of x square plus 1 we put t, that is t square, and in the place of x dx we got dt by 2, because we can replace only x dx here. That's why x dx is equal to dt divided by 2. So after substituting, you can see 1 by 2 is constant that we can take outside. Then integration of t square is t cube divided by 3, and the limits are 1 to 2. Again, 1 by 3 is a constant. We can take it outside. It becomes 1 by 6. Now, if you apply upper limit, it is 2 cube minus apply lower limit, that is 1 cube. Then 2 cube is 8 minus 1 cube is 1. So we get 8 minus 1 is 7. So answer is 7 by 6. Therefore, integration from 0 to 1 x into x square plus 1 whole square dx is equal to 7 by 6. Now we move on to the another one. Evaluate integration from 0 to pi by 2 cos x divided by 1 plus sin x dx. Here it is of the case, here it is f dash of x and this is f of x. That means it is of standard form. Integration of f of x, f dash of x divided by f of x is log of f of x. That is a standard formula. Otherwise, you can do it by substitution method. That means we have to take this equation as equation number 1. Put 1 plus sin x equal to t. Because if you differentiate this, another term vanishes. So put 1 plus sin x equal to t, differentiate with respect to x, we get differentiation of 1 is 0, differentiation of sin x is minus cos x dx. So differentiation we are doing. So differentiation of sin x is cos x dx and differentiation of t is dt. Also we get cos x dx is dt. Also we have to change the limits here. That means when x equal to 0, sin 0 is 0, we get t equal to 1. Also when x equal to pi by 2, sin pi by 2, that is sin 90 degree, sin 90 value is 1, so it becomes 1 plus 1, 2. Therefore, we get t is equal to 2. When x equal to 0, then t is equal to 1. When x equal to pi by 2, then t is equal to 2. So substitute all these values in equation 1, we get integration from 0 to pi by 2 cos x by 1 plus sin x dx becomes, in the place of 0, you can put 1. In the place of pi by 2, you can put 2. In the place of cos x dx, you can put dt. In the place of 1 plus sin x, you can put t. So finally it becomes integration from 1 to 2 dt divided by t. And then integration of 1 by t is log t between the limits 1 to 2. Then if you apply upper limit and lower limit is 2, lower limit is 1. Therefore, log 2 minus log 1. And log 2 we will keep as it is, and log 1 value is 0. So we get the final answer is log 2. That is integration from 0 to pi by 2 cos x by 1 plus sin x dx is log 2. Now we will evaluate integration from 0 to 1 tan inverse of x whole square divided by 1 plus x square dx. We call this equation as equation number 1. Now we have to put tan inverse of x equal to t. If you put tan inverse of x equal to t, then differentiate with respect to x, we get differentiation of tan inverse of x is 1 by 1 plus x square. You know that differentiation of tan inverse of x is 1 by 1 plus x square into dx is equal to dt. Also, when x equal to 0, tan inverse of 0 is 0. Therefore, t equal to 0. When x equal to 1, that is tan inverse of 1 and that value is pi by 4. Therefore, t is equal to pi by 4. When x equal to 0, then t equal to 0. When x equal to 1, then t equal to pi by 4. Substitute all these values in equation 1, we get integration from 0 to 1 tan inverse of x whole square by 1 plus x square dx is equal to, in place of 0, put 0. In place of 1, put pi by 4. Then tan inverse of x is t, so it becomes t square. And 1 divided by 1 plus x square dx is dt, so we got dt here. So this equation transformed as 0 to pi by 4 t square dt. And then integration of t square is t cube divided by 3 between the limits 0 to pi by 4. Now apply upper limit and lower limit. 1 by 3 is a constant, take outside. T cube means pi by 4 whole cube minus, again lower limit is 0 cube. So if you simplify, pi cube divided by 4 cube is 64. So final answer is pi cube divided by 192. That is 0 to 1 tan inverse of x whole square by 1 plus x square dx is pi cube divided by 192. Now we will evaluate integration from 0 to 1 x into e power x dx. This equation we solve by using integration by parts. Okay, the same method we call it as equation number 1. Then we know that integration by parts method, that means integration of uv dx is u into integration of v dx minus integration of v dx into differentiation of u with respect to x into dx. And also that is LIATE rule. Here algebraic term, then exponential term. So algebraic term can be taken as first term, then exponential term can be taken as second term. Then by using integration by parts, we can write it as integration from 0 to 1 x into e power x dx equal to first function into integration of second function minus integration of second function into differentiation of first function into dx. So x is first function, e power x is second function. So x into integration of e power x dx minus integration of e power x dx into differentiation of x with respect to x into dx. That is what second integration by parts rule, and that is how you have learned previous this session. Okay, so if you substitute here, x into integration of e power x is e power x minus integration of e power x dx is e power x. Differentiation of x with respect to x is 1 and remains with dx. Again, what is integration of e power x? E power x. So finally it remains with x into e power x minus e power x. So between the limits 0 to 1. Once you complete this integration by parts integration, then we have to apply the limits here. So first apply upper limit in the place of x 1 into e power 1 minus e power 1. Then minus of lower limit is 0 into e power 0 minus e power 0. Okay, so here 1 into e power 1 minus e power 1 minus of 0 into e power 0 minus e power 0. If you simplify, e power 1 into 1 is e power 1 minus of e power 1, this is 0 and e power 0 is 1 and minus of minus is plus. So these two will get cancels, we get the answer is 1. Therefore, the final answer is 0 to 1 x into e power x dx is equal to 1. That is the final value of integration from 0 to 1 x into e power x dx equal to 1. Now the last problem in this one is integration from 0 to pi by 2 x sin x dx. Again here this problem can be evaluated by integration by parts method. Again according to LIATE rule, algebraic terms come first, then sin x next. Therefore this is first function and this is second function. Then by using integration by parts, we get integration from 0 to pi by 2 x sin x dx becomes first function into integration of second function minus integration of second function into differentiation of first function into dx. So x is first function, sin x is second function. We get x into integration of sin x dx minus integration of sin x dx into differentiation of x with respect to x into dx. If you simplify, integration of sin x is minus cos x, so it becomes minus x cos x. Then here again integration of sin x is minus cos x, so it becomes minus into minus plus integration of cos x. Dx by dx is 1, so we get integration of cos x dx. Therefore, integration of cos x is sin x. Finally, we get minus x cos x plus sin x between the limits 0 to pi by 2. Now apply in the wherever x is there, apply upper limit is pi by 2. Next take minus, then wherever x is there, put 0. We get minus pi by 2 into cos pi by 2 plus sin pi by 2. Here x is there, minus pi by 2. Cos pi by 2 plus sin pi by 2 minus of here x is there minus 0 into cos 0 plus sin 0. So if you simplify, minus pi by 2 into cos 90 is 0, so we taken 0. Sin 90 is 1, we taken 1. Cos 0 is 1, but 1 into 0 is 0. Sin 0 is 0. So this value becomes 0, this value becomes 0, this value becomes 0. Finally, it remains with 1 and that is the required solution. Integration from 0 to pi by 2 x sin x dx equal to 1. So that is all from problems from integration by parts and substitution method. I have given some assignment questions here. You can try it by using integration by parts method also and some substitution method. Okay. First 5 problems are from substitution method. Here put sin x equal to t. Here you can put tan x equal to t. Here you can put 1 plus tan x equal to t. Here you can put 1 plus cos x equal to t. Here you can put sin inverse of x equal to t. Here you can use integration by parts method. Here also you can use integration by parts method. Last two problems are integration by parts and first 5 are by substitution method. Now we discuss one multiple choice question here. The value of 0 to pi by 2 sin x cos x dx is minus 1 by 2, 2, minus 2 and 0. So sin x cos x dx, you can see if you put sin x equal to t, differentiation of sin x is cos x dx equal to dt. Therefore we get t dt. T into dt it will become. Also limit changes from 0 to 1. So integration of t is t square by 2. Then if you apply the limit, the answer will become 0. Okay, the final answer is 0. Or you can take sin x cos x can be taken as sin 2x divided by 2. Integration of sin 2x is minus cos 2x divided by 2. Okay, minus cos 2x by 2 ಆಗುತ್ತೆ. So minus cos 2x by 4 ಆಗುತ್ತೆ ಅಲ್ಲಿಗೆ. Then minus cos pi by 2 minus cos 0. So we get the answer is 0 here. Then another one is the value of integration from 0 to 1, 1 by 1 plus x square dx is pi by 3, pi by 2, pi by 4 and 0. So here 1 by 1 plus x square means it is tan inverse of x dx. Tan inverse integration of 1 by 1 plus x square is tan inverse of x. Tan inverse of 1 minus tan inverse of 0 and tan inverse of 1 is pi by 4. That is option C, pi by 4. So that is all from this session. So in this session we have discussed about simple problems on definite integrals, evaluating definite integrals by substitution method, assignment problems and some multiple choice questions. So in the next session we are going to discuss about applications of definite integrals, area enclosed by a curve, problems to find area under the curve, assignment problems and multiple choice questions. So thank you for watching this video. Thank you.